Deep in the hangar, the fighter jet sits in silence, but its engine is a giant of physics. Unlike a car, this machine breathes fire. It gulps enough air to fill a stadium in minutes, then compresses that air until it's white-hot to create the massive thrust needed for flight. The journey begins at the intake, where titanium fan blades spin with enough force to pull objects in from yards away. These blades pull in the atmosphere, carved from specialized alloys that withstand hurricane pressure while spinning at over 10,000 rotations per minute. Inside, the air enters the compressor, a series of tunnels lined with spinning blades. Here, air is squeezed until pressure is 30 times higher than outside. This makes the air so hot it glows, preparing for the explosion that will push the aircraft past the speed of sound. In the combustion chamber, fuel is sprayed into this high-pressure inferno. The resulting flame burns at temperatures that would melt almost any metal. To stop the engine from melting, engineers design cooling air that coats the walls like an invisible, protective icy shield. The energy from this explosion rushes through the turbine, acting like a high-tech windmill. The turbine steals just enough power to keep the front fan spinning. These blades are often grown as a single crystal of metal to ensure they have no microscopic weak points or flaws. The leftovers of this explosion create thrust. As gas screams out the nozzle at supersonic speeds, Newton's third law takes over. The gas goes backward with 40,000 pounds of pressure, and the sleek metal jet is shoved forward into the sky at incredible, lethal speeds. For extreme needs, pilots engage the afterburner. This is a raw fire hose of fuel sprayed into the exhaust pipe. It creates a massive plume of fire that doubles power instantly. While it drains fuel like an open tap, it provides the raw violence needed to win a modern dogfight. Modern engines are also masters of stealth. In the past, the heat signature was like a lighthouse for missiles. Today, engines mix cool air with hot exhaust before it leaves the pipe. This masks the thermal footprint, allowing the pilot to operate like a ghost in the clouds. The future lies in adaptive cycle technology. Engines are usually good at speed or saving fuel, but rarely both. New designs change their internal shape mid-flight. They act like a fuel-sipping airliner when cruising and transform into a racing machine for intense combat. Sixth-generation propulsion integrates the engine with a plane's brain. These future engines won't just provide thrust, they will act as massive power generators. They will provide the electricity needed for laser weapons and jamming pods that blind entire enemy radar networks. We are seeing the rise of hypersonic scramjets. These engines have no moving parts. They rely on the sheer speed of the aircraft to compress air. Flying at Mach 5, a scramjet-powered fighter could cross the United States in 30 minutes, moving faster than a rifle bullet. AI is now entering the engine room. Future jets will have self-healing engines that detect microscopic cracks before they happen. The AI can adjust fuel flow to reduce stress on the damaged part, allowing the pilot to return home safely from a mission that would be fatal. Sustainability is finding a place in the cockpit. Military researchers are testing engines that run on synthetic aviation fuel made from carbon captured from the air. The goal is a jet that doesn't rely on oil supply lines, making the engine as independent as it is powerful. One radical concept is the plasma actuator. This uses electricity to turn the air around the engine into plasma, reducing drag and noise. This would make jets nearly silent and significantly faster, allowing them to slip through the atmosphere with almost zero air resistance. The fighter jet engine is the ultimate expression of human ambition. It represents our desire to conquer gravity and the limits of biology. From crude turbojets to the digital hearts of tomorrow, these machines remain the most complex and powerful objects ever built by man. The vantage point on aviation is clear. The engine is becoming a thinking organ of the aircraft. The fire in the vault is getting smarter and faster, ensuring the sky remains the ultimate frontier. The future of flight is not just about power, but about total intelligence.